So what we're going to talk about is actually an application of blockchain rather than blockchain itself. Okay. So what Gospel, we'll tell you a little bit about Gospel. We'll tell you a bit about some of the use cases that we've seen in Salesforce, and then we'll talk about, and then we'll kind of, Rushy's going to kind of take over and show you under the covers all the kind of clever stuff that I don't know about. You are, right?
Yeah.
Okay, good. Right.
No, I'm running away.
Just so I get that straight,
Yeah.
because otherwise we're in trouble. Because if I try and describe that, we are not going anywhere. So we'll just kind of, tell you a little bit about Gospel. So Gospel is basically a secure distributed database. It's designed specifically for sharing sensitive data. It, in Salesforce terms, it sits outside of Salesforce. I'll explain how that kind of works in a bit. We have an app which went live 4 weeks ago on the App Exchange. And we're actually Salesforce's first venture in, Salesforce Ventures' first investment in any blockchain technology. And so what that kind of means is that they kind of saw what we were doing. They obviously knew what they were doing with their own kind of blockchain offering. They're separate. They're not the same. They're not the same system, and they provide quite different things. So what it kind of looks like is at a kind of high level. It's as I said, it's a secure distributed database. Everything in it's encrypted. It's secure. And what we did was we started from the point of view that a lot of people, when they share data, they do it insecurely. And so what we do is we say, okay, look, here's a lump of data that I want to do something with. First off, let's secure it. Let's put a kind of comfort blanket around it. Let's encrypt it. Let's digitally sign it. Let's kind of distribute it around this distributed database system. And then what we're going to do is we're going to use blockchain to provide the kind of read-only, a read-only versioned history of everything that's everything that's happened in that environment. And that's great, let's take blockchain, but then it's not much good unless you actually integrate that with other systems. So we've kind of spent a lot of time building connectors for different systems. We've got obviously the app for Salesforce. I'll show a slide in a minute with some of the connectors for data sources that we can pull out, and kind of so that's the kind of integration story. From an access point of view, it's like how do you actually get access to that data? Again, it might be through APIs. But what we're basically doing is providing, at its core, it's a database, right? So we have records, we have views, we can join record tables together. We can do all the kind of normal things that you expect in a database, but it's distributed, it's blockchain, it's got this kind of worm versioned history. And it's tamper-proof. And basically the data governance that kind of sits behind it supports all the kind of things that you would expect from a GDPR point of view. We can put individuals can upload data into the system. They can manage their own data. So at no point do you lose control of your data that you're putting into the system, and that's kind of quite key because in a lot of blockchain systems, first off, you have to store. If you want to take part, in the blockchain, you have to store a copy of every single piece of everybody's data that's in the blockchain. What we do is we kind of say, okay, well, if you've got people who are, primary participants, then yeah, they may need to do that. But what if you've got an individual who wants to upload and register on a system? Just me at home registering with my local council or with a pharmaceutical company because I'm going through a clinical trial or something. It's not practical for me personally to have a copy of everybody's data in that chain. So we've figured out a way of allowing people to take part in the system without actually having a copy of all of the data. So kind of to sort of give you an example here, I guess this guy up here you'll probably recognise, Dexter. But the way kind of data sharing works today is if we take this example in a pharmaceutical environment, we've got a pharmaceutical company. Let's call it Dexter's Pharmaceutical Company. Why not? And they basically produce drugs. And what they need to do is share some of their information with the Drugs Research Institute and also with Lurgy-Camp Clinical Trials. And you might laugh at that name, but there is actually a company called flucamp.com. But basically, they've got data. They want to share it with the Drug Research Institute. What they do is they kind of process results from clinical tests, and they advise the pharmaceutical company on their kind of portfolio of products and drugs that they might have. And we've got kind of Dexter here, who's in charge of his a new drug. We've got Norman over there, who produces this probability of technical and regulatory success report, which goes back to to Dexter. And obviously, there's a lot of kind of supporting data that kind of goes with that. And then we've got down here Verity, who works for the Lurgy clinical trials. And basically, what they do is they find out how a particular drug might work against a particular virus or disease, and they sign up all of these kind of trial camp attendees. And those might be residential. You might put people in quarantine, or there might be, whatever. The way that this process works at the moment is that, Bill down on the bottom right there wants to take part in a clinical trial. He fills out a paper form. He sends that off in the post, and then he may get an email back. He may get a letter back, but he's kind of quite detached from the system. And what actually happens when you think about the way that these organisations share data today is that really what they do is they go into one of their core systems, they run a report, they export that to their local machine, then they attach that to an email, and then they send that. And quite a lot of the time. So first off, we now have 4 copies of the data. We have the original copy of the data. We have a copy that's now sat on my desktop, a copy that's sat in Rushy's inbox because I'm sending it to Rushy, and one that's sat in my outbox. Okay, and only one of those versions of the data is actually up to date. So let's kind of think about things like GDPR, data privacy, security, all the kind of things that are kind of hot in the press at the moment. It's kind of not really the way we want to be sharing data today. So if we kind of map our data sharing onto how Gospel might do that and how Salesforce would come into that, we end up with a kind of diagram that looks a bit like this. So at the core, we've got Salesforce. We've maybe got Dexter's Pharmaceuticals here. They've maybe got a Lightning application with our Gospel connector. And this is a custom app that they've written themselves that works for their line of business. They've got their connector, which is essentially our SDK for Salesforce. Maybe a Gospel node, and these sit obviously inside Salesforce. And then they've got a Gospel node. That node will carry a copy of all of the data that they're pushing into it. Some of that might come from one of these data sources, might even come from Salesforce. But they can kind of basically pick data that they want to share and then decide what views on that data they're going to make available to other organisations. And they can push that into the Drug Research Institute, into their own Lightning application, if they've got their own Gospel connector. They don't even need actually to have a Gospel node with a copy of the data. They can use the node which we've got over here. And then down the bottom here, we've got Verity, who's working for Lurgy Camp, and she actually works with citizens and people who generally will not have Salesforce. So I mean, let's kind of be honest. So not everyone's going to have Salesforce. I don't have Salesforce as a home user. Actually, I do, but slight lie there. So basically, what she's done is she's written, or her organisation has written a web application that allows people to come in, register, and they're in control of their own data. They upload their data. They can the pharma or the Drug Research Institute can say, oh, you know what, I'm really interested in this particular patient's diagnosis or the symptoms that they've got. Can I contact them for an interview? And we can actually put in place a process which allows the Drug Research Institute to request access to Bill's personal data. Bill can get an alert in the system, and then he can just say, no, do you know what, I'm not interested in that, or yeah, I am interested in that. So, but the whole kind of foundation is built on making sure we're putting the right data in front of the right people at the right time. Okay, and we can do that down to the individual field level. So not just a case of saying, bang, here's a record. It's like, here's a field. Or maybe even what we can do is mask the fact that there are 25 people in the RG7 postcode over the age of whatever. We'll just give them a number, so we can actually mask the kind of raw data that's sitting behind, sitting in the data when we create those views. So what Rushy's going to go into is a use case that we've built around a home builder. So I don't know whether anyone was at the Construction Council last week. Anyone? Yeah. Particularly relevant there. A couple of the people we kind of been talking to quite a few of the people in the room there, And basically, we've got this organisation that we're working with who want to share data with third parties. And at the moment, what they do is they go into Salesforce, they run an export, they take that export, they put it onto their local machine, they attach it to an email, and they send it to either a surveyor or a land registry or the mortgage broker. Not ideal, I have to say, because they're actually sending personal information across those links. And yeah, okay, they password protect the file and do a bit, but actually what they're doing is they're oversharing data. They're not kind of going through and deleting the columns and the rows and the fields that the destination user actually doesn't need to see. They're just kind of saying, oh look, yeah, export, right, here's a password, bang, off it goes. And that's part of the problem with this. Once you share that data, you don't know what happens with it, and you're oversharing data and under-securing it. So I'm going to hand over to Rushy now.
Yes.
Who's going to show us how this stuff all works.
Do you want to take your laptop?
Oh, yeah, sorry.
Okay. Can everyone hear me? Mm-hmm. So, yes. So let's go through the code and what challenges are faced while creating the connector in Salesforce. But let's start with, so the purpose of the connector is to seamlessly get and post data into Gospel backend, because we are a database. So in order for that to work seamlessly, what we need is a valid certificate, which can be stored in the Salesforce certificate store. Once all that is configured, so I think that certificate needs to be signed by a CA from Gospel, and then that can be imported into the certificate store. But once that's configured, you're ready to go. So a developer can build on top of the Salesforce connector and basically create dashboards, create views, whatever they want to do, and play around with the data that they get back from Gospel. So one thing I was going to show was, so here's the meat of the whole thing. Oops. Sorry. Can't. What? Here we go. Right. So basically, when we started the project, we were looking at the different technologies available at the time with Salesforce, and we found that we can inherit from the data source connection library. Okay, maybe remove that. Sorry. Yes.
Increase the font size?
Yes, you can.
It's the same as Chrome.
Yep.
Because it's that.
It's not doing it. Can you see it?
Yeah, Zoom is
It's a bit small. Maybe you can send us all a copy of it by email?
That's a good one. Right, so basically, all I wanted to say here is we inherit from the library that's provided by Salesforce, and it contains all the basic put, posts, get functionality. But the really fun part that comes in is creating the payload for each request. So as an added layer of security in Gospel, for every request you make, we kind of add a very specific, unique signature to each request. So what happens is, say in this dashboard that I have created here, if I can drag it, this is essentially getting data from the back end of Gospel. So say you reload this page, it says, okay, get me the partner records from the view that we've created in Gospel. And what it does is it creates a unique signature. And that signature is then signed, unique payload. That payload then gets signed by the certificate that's we've stored in Salesforce, and then hex encode it, and then put it in the request header and send it off to Gospel. So Now, if I go back in there and what is it? Sorry, that's a bit squishy. Okay, great. So what happens when the request gets sent to the Gospel backend is it verifies that the certificate is valid and also rechecks that the signature that's been sent from Salesforce is correct. So if it's not correct, it will log it because we're in a mutable ledger. So it will log that, okay, this user tried to access our data, but they weren't successful because they don't have the rights, or the signature that they've sent us in the request is wrong. So what will happen, that'll get logged and you will get an error in response. But if it is successful, what will happen is the request will get validated and send the correct data back into Salesforce. And the Salesforce developers or whoever's using it, they will have a dashboard or data or diagram, whatever they want to do with it. They can basically manipulate it if they want to. We offer that option, but in this use case, these guys just wanted a read-only dashboard. So we've kind of just did that for them. But yeah, here's the live data if you guys want to have a look at that as well. But yeah, this is the data. So this is then shown in the Salesforce dashboard that we've created. And that's it.
Right.
Yeah.
Okay.
Cool. Thank you guys.
Yeah, can we switch back to There we go. So basically, you know, kind of what's next. So what we've done is we've put Gospel onto Google Cloud. You can deploy it in 15, 20 minutes. You know, I'm no Kubernetes expert, but I managed to get it going in about 10 or 15 minutes. It's a wizard. You kind of click next, and in 15 minutes, you've got a demo system up and running that you can start playing around with. In the App Exchange, there's the connector. You can just search for Gospel, and it kind of comes up. We can let you have that. And so basically, and then if you want the code for the home builder application that you saw today, we've actually also written code to push and push data and edit data in Gospel. So that's another kind of, you know, additional kind of capability which we didn't mention today. But we can make all of that stuff available to you. And we're kind of here to help if you want to kind of start playing around with this at your leisure. That's it. Thank you. Any questions?
Is that Google thing free?
So when you sign up, you get, if it's a new account, you sign up, you get $300 credits for free.
Oh, wow.
Yeah. Yeah, there's no charge for the Gospel. We're just, you know,
It's an opportunity for you to try out your use cases where you might want to share data with third parties or individuals within your enterprise who you may need to give access to data, but they're not in the enterprise at all time, and you don't need to necessarily pay for enterprise licenses through Salesforce. So it's a good way of trying to give them access to data, but you can control of it when it's outside of your enterprise as well.
You said at the start this isn't competitive to Salesforce blockchain, so just for the audience here, can you explain where you sit on a Salesforce blockchain, which is going to be a big focus of the course today?
Yeah.
Where you sit alongside,
sure.
Complementary or
yep. How it works? So the Salesforce blockchain pretty much operates internal to Salesforce. What we're doing is we're taking data that wouldn't necessarily otherwise be surfaced in Salesforce, and we can show it in Salesforce. So you can see your Salesforce data alongside your kind of I don't know, highly volatile data that's sat on your internal network with about 700 systems that feed into it that you're never going to ever be able to migrate into Salesforce. So that's kind of one sort of area. No, I mean, there's no reason that you wouldn't use both. I mean, what we're not saying is kind of pull all your data out of Salesforce and stick it in Gospel. I mean, that would be a bit silly. And that's not kind of what we're about at all. It's about making sure that you can share data that maybe you've got in Salesforce, and instead of exporting it, you can put it into Gospel, synchronize it with Gospel, and then push it into somebody else's environment, whether that's Salesforce or, albeit some people don't have Salesforce, so we can have a web application that serves that data for them, or in fact, if they've got an application where they're manually loading that data in, you could actually use our APIs to push that data in. So we've got these clever things called watchers, which basically allow you to monitor data that's inside Gospel. And then if we see a certain change, we can say, oh, right, okay, so make this happen, and it can kind of run code to push data into a target application. So what we're doing there is making sure that you've always got the latest version of the data, there's an immutable audit trail, it's encrypted end-to-end, so you get the kind of full security of it. But it's more about data that's outside of Salesforce rather than data that's in Salesforce, if that kind of makes sense.
We've both took a common use case, which I think most of us have had to do in the past. Let's say they have an order management system in Salesforce, and they made a customer master, constant challenge, implementing a centralized customer master. Would you use Gospel for that, so you had one customer master in all your systems?
So yes, I mean if that's data sitting outside on your internal network, and because let's face it, some customers are not ready to migrate certain data into Salesforce. Some of them they kind of go, well, actually, do you know what? We're not able to do that. It's kind of cost prohibitive. So what we can do is show that view that that Rushy showed. You can make that available to internal line of business, or what you can do is you can make the edit or new field ability available to those users, so actually, although the data is still sat on their internal network, they're managing it from within Salesforce, and what that's doing is obviously cementing that corporate dashboard in Salesforce.
So where you've got, my understanding of blockchain is a little bit good, but basically you're sort of distributing the data around different parties who are validating it.
Yeah.
Right? So how does that impact with GDPR and people who are worried about what country their data's in and all that kind of stuff?
Sure. So whoever put that data in the first place retains control of it, so they can decide who can view it, under what circumstances they can use it, if you like, what context they can have when they're able to view it. So in theory, what you could do is, we haven't actually practiced this, but maybe we should. You can take one of our nodes, stick it into an air-conditioned unit in the middle of nowhere with a kind of crossover cable on it, and you're not going to be able to access the data that's on it because it knows from a consensus point of view that it's part of a 3-node network, and you can't kind of brute force the data.
So if you're in a 3-node network,
Yeah.
obviously you're going to know presumably where those nodes are. If it was a much bigger network. If a customer says, I don't want my data to be outside of Germany, for example, how do you manage that?
So you can set, basically, based on the nodes that you've got. So first off, this is a private blockchain. Maybe I didn't sort of make that clear. It's not a public blockchain in the same way that kind of a Bitcoin might be, where you can just kind of say, oh yeah, I want to take part in that, and off you go, and then you get a copy of the data. That's not how this works at all. So typically, it'll be business relationships between organisations that want to or need to share data and some of that might be highly sensitive.
Right. If I've got my data in there, and so let's say I'm not the owner of the blockchain, if you like, but I've got my data in there, and I could have a contract with you that says my data can't go outside Germany. You say fine, but that would mean that you could never ever then have a node that was outside of Germany, for example, because
you'd have it but you can't just randomly join the network because it's private. So
you'd have that sort of restriction imposed.
I think it's so with Gospel, what you have is a box of data. So we sort of think about it as like Schrodinger's box. You know, Schrodinger's cat is a cat in the box, sort of yes or no. With Gospel, you have a box of something, and until the system has verified you through your own key management and integration to what you can see, you won't be able to see anything in that box anyway.
Yeah, but the fact you can't show it doesn't mean it's not there, though, does it?
It's all to do with
it does,
access.
because legally it is there.
But it's not because encrypted
How has
data is
legislation caught up with that?
Well, no, do you know we're in this discussion with a big pharmaceutical
Right.
company, and especially around the right to be forgotten. So
Yeah.
the whole forgetting from your system. If you were to do it today in a database, unless you stick a GoPro on an engineer's head and he drills through every single server you've ever had, and how do you even know that he actually deleted all the data? Whereas with gospel, what we're seeing is you can forget data, and data is no longer accessible to anything, to anyone in the system. But you may get a case where in 10 years' time in a clinical trial, an effect hits a person that's already been forgotten. So under a court of law, you actually have to retrieve that record. So actually with gospel, we've got a mechanism to both forget data and it's no longer accessible at all, and also being able to retrieve data when you need it, should you need it through a court of law. Some of the stuff we do around in the nuclear world, you've got data retention for 100 years after the nuclear plant's been finished. So if a supply has been forgotten and then something goes wrong in year 67, you've got to retrieve that data. So it's, with some of our lawyers that we work with and our customers, it's like a bit of a mindset shift, because if you need a node in Germany and nobody can ever access any keys in Germany, you can set that up. It's whether the lawyers will be okay with that, and some are and some aren't.
Right.
This is cutting edge data, regulation stuff at the moment. So
A little bit ahead of the legislation, really.
the innovator in me wants to say yes.
Yeah.
The reality is, every customer engagement that we work with is quite different at the moment. Some people are bought into this key management world, and others are saying if the node is in Germany, and even if it's encrypted, it doesn't matter because it's still there. So it's just, it's all interpretation. Yeah, but if you look at it over existing databases, and spreadsheets, and local copies of everything, it's a far better solution. You know what I mean? So, yeah, I think it's just worth saying that, really.
Yep.
I'm going to shut up and go back to the room.
Any other questions?
Does it need any smart contract access?
Yeah, so we have a capability internally for smart contracts. So, as data comes in, we can make decisions over, where data is written internally, and maybe what views are available to users, those sorts of things. Yeah, and that's written in the Lua language.
Okay. Yeah. Thank you.
So, probably leading on from that legal stuff, what about law enforcement? So I'm a bad guy and I buy your system and I store really bad data in it. Am I protected from the police, or can they come in and subpoena you and get the data out?
Well,
what did you say you do?
Well, I mean, we only trade with nice organisations. That's the first thing I should point out. But no, I mean, in theory, you put something in. If you take any kind of encryption, you can kind of encrypt it and make it unrecoverable by law enforcement in theory. But within the system, I mean, there is no backdoor to the system. The network basically has to give you consent, give you as a user when you authenticate against the system consensus to access the data that's being made available. But there is no backdoor to the system. Maybe we should build, but no, don't say that.
Well, no, that's it.
Okay.
Cool.
Well, thanks very much. There are
Thank you,
t-shirts
guys.
outside and some beers.
Thanks, guys.